Did someone decide, wow, I'm gonna respond? But they don't speak English, so their message is a computer message. Is that first contact?
NASA, renowned for its leadership in space exploration, has stunned the scientific community with its latest revelation. Voyager One, humanity's most distant spacecraft, has made a discovery of such magnitude that NASA deemed it necessary to cease its transmission. Speculations abound, ranging from potential evidence of extraterrestrial life to groundbreaking insights into the laws of physics, or even phenomena beyond our current comprehension. What could be the nature of this discovery that prompted such a dramatic response from NASA? Join us in this journey as we unravel NASA's latest warning about how Voyager One has made an impossible discovery before it got shut down. Number 1. Voyager One's historic journey. The highly anticipated launch day for Voyager One finally arrived at Cape Canaveral Air Force Station in Florida. However, a small glitch with the rocket's guidance system caused a nerve-wracking delay of 2 weeks. But, on September 5, 1977, Voyager One began its historic journey, shooting into the sky on top of a Titan Three-E Centaur rocket. As it said goodbye to Earth, Voyager One started a mission that needed incredible speed, choosing a faster route compared to its twin, Voyager Two, which had launched just 2 weeks earlier. Assigned with the massive task of uncovering the secrets of our solar system, the Voyager probes exceeded everyone's expectations, exploring unknown parts of the universe. Voyager One, especially, began an extraordinary adventure that still surprises NASA and the global scientific community today. Even though experts initially thought Voyager would only last about 5 years, it has defied the odds, continuing its mission for decades. This ongoing journey of discovery speaks volumes about the amazing craftsmanship and innovation behind the Voyager spacecraft. Built with cutting-edge technology far ahead of its time, Voyager One and its companion, Voyager Two, were engineering marvels. Every part, from the engines to the antennas, was carefully designed for durability and effectiveness. Taking cues from the Mariner spacecraft, NASA engineers made clever adjustments, outfitting Voyager One with a variety of advanced scientific instruments. These instruments, totaling 11, included things like ultraviolet spectrometers, cosmic ray detectors, magnetometers, and high-resolution cameras. With such advanced gear, Voyager One embarked on a thorough exploration of the celestial objects and phenomena nearby. Now, a groundbreaking discovery that would change the history of space exploration is on the verge of being uncovered. Number 2. The terrifying secrets of our solar system. Gary Flandreau, a key figure in NASA's space exploration missions, played a crucial role in steering the course of the famous Voyager One spacecraft. Despite not getting much recognition, his efforts were vital for the success of the Voyager missions. Flandreau's journey with NASA began in the mid-1960s at the Jet Propulsion Laboratory, JPL, where he made a groundbreaking discovery that would change the history of space exploration. During his time at JPL, Flandreau identified a rare planetary alignment involving Jupiter, Saturn, Uranus, and Neptune, expected to happen in the late 1970s and early 1980s. This celestial event, occurring once every 175 years, provided a unique chance for spacecraft to use gravitational assists. Gravitational assist, also called the slingshot effect, involves a spacecraft using the gravitational pull of a planet to boost its speed and change its path. By carefully planning the spacecraft's path, engineers could utilize this effect to send it on long journeys through space with minimal fuel usage. Recognizing the potential of this planetary alignment, Flandreau suggested an ambitious Grand Tour mission. This mission would use gravitational assistance to send a spacecraft on a journey through the solar system, passing by each of the outer planets one after the other. The path Flandreau proposed would allow the spacecraft to collect valuable data as it passed each planet, sending this information back to Earth. This innovative idea transformed space exploration, enabling missions like Voyager to travel vast distances with unmatched efficiency. Flandreau's discovery sparked a revolution in space exploration, offering extraordinary insights into the outer reaches of our solar system. His proposal not only promised to gather ground-breaking data about distant planets, but also aimed to do so much faster than traditional methods. By making use of gravitational assists, the mission could save precious fuel resources, making it achievable with the available technology at the time. However, with great potential came great challenges. Plotting a trajectory to use gravitational assists from multiple planets required precise calculations and timing. The spacecraft had to arrive at each planetary encounter with exact precision, ready to receive the gravitational boosts needed to propel it forward. Any deviation from the carefully planned route or technical malfunction could jeopardize the mission. Additionally, the vast distances of space posed significant obstacles to communication and data transmission. To overcome these challenges, the spacecraft had to be equipped with advanced instruments capable of withstanding the harsh conditions of deep space and transmitting data across billions of miles. Despite these challenges, Flandreau's proposal sparked enthusiasm within NASA. The scientific benefits promised by the Grand Tour mission were too tempting to ignore. However, due to budget limitations and technical challenges, NASA decided to modify the mission's scope. Instead of sending a single spacecraft on the ambitious Grand Tour, the agency launched two remarkable vessels, Voyager One and Voyager Two. While Voyager One focused on Jupiter and Saturn, Voyager Two aimed to explore Uranus and Neptune if its initial objectives were successful. While Flandreau's Voyager One explorations have been highly innovative, what's coming up next is probably Flandreau's most stunning innovation yet. Number 3. Exploring the biggest planet's mysteries. In November 1977, Voyager One smoothly traveled through the asteroid belt without any trouble. But the most exciting part came in April 1978, when Voyager 2 began to closely observe Jupiter from an incredible distance of 165 million miles away. The highlight was on March 5, 1979, when Voyager 1 passed closest, getting just 217,000 miles from Jupiter's swirling clouds. This event marked Voyager 1 as the second spacecraft to come so near to Jupiter, but its importance went beyond just being first. Voyager 1 led the way in discovering Jupiter's secrets. During its flyby, it found some surprising things. It spotted a thin ring around Jupiter that hadn't been noticed before. This ring, made of dusty leftovers from Jupiter's inner moons, was less than 19 miles thick and circled about 50,000 miles from Jupiter's center. Also, Voyager 1 spotted two new moons, Thebe and Metis, playing around within this ring. These moons, known for their small size and odd shapes, added to the cosmic show. Voyager 1's exploration of Jupiter also uncovered another amazing finding, the intense activity on Io, one of Jupiter's moons. Jupiter, the biggest planet in our solar system, has an impressive group of 79 known moons. Some of these moons orbit very close to the gas giant, nestled within its beautiful rings. However, the most famous of Jupiter's moons are the four powerful Galilean moons, named after the famous astronomer Galileo, who first saw them in 1610. The Voyager missions spent a long time studying Jupiter and sent back heaps of information about it to NASA. Voyager 1 zoomed past Jupiter's shiny rings before reaching its four biggest moons, Io, Europa, Ganymede, and Callisto. These moons are huge and have their own special traits and mysteries waiting to be discovered. Io is the closest of Jupiter's big moons and does a fascinating dance near the planet, floating about 350,000 kilometers above Jupiter's swirling clouds. If you were standing on Io, Jupiter would look huge in the sky, about 39 times bigger than our moon. But Io's close distance to Jupiter means it moves fast, completing one orbit around Jupiter in just 42.5 hours, much quicker than our moon's monthly orbit. This speedy orbit makes Io even more mysterious. What's even more interesting about Io's orbit is that it syncs up with its neighboring moons, a cool thing called orbital resonance. For every orbit of Europa, Io completes 2 orbits, and for every orbit of Ganymede, Io completes 4. This gravitational dance affects Io's orbit, causing strong tidal forces that make its surface very active geologically. When Voyager One flew by Io, coming as close as 2,000 kilometers, it took amazing pictures of Io's surface, showing its turbulent and volcanic nature. Voyager One's visit to Io revealed a world full of surprises. Instead of the usual barren, crater-covered moons, Io's surface was colorful and lacked impact craters. There were tall mountains, as tall as Mount Everest, and huge volcanic pits, hundreds of kilometers wide, showing off Io's volcanic past. Frozen lava covered the ground, telling the story of Io's fiery history. One of the most amazing discoveries was the plumes shooting out from Io's surface. This was the first clear proof of volcanic activity on Io, making it the only place, apart from Earth, in our solar system where such activity has been seen. Voyager 1 also found that Io's surface is covered in different colors of sulfur frost, making it look like a colorful patchwork. Another interesting thing about Io is that it doesn't have typical volcanic calderas. Instead, there are big lava lakes surrounded by steep walls where most of the volcanic action happens. The biggest of these lakes, called Loki, is an impressive 200 kilometers wide. These lakes have a thin crust covering them and are connected to underground lava reservoirs. Loki, especially, is always changing, affecting Io's overall heat. Normally, it produces a quarter of the planet's heat, but sometimes the crust collapses, making heat production increase tenfold. These events show how dynamic and fascinating Io is. In the latest discovery, certain types of new moons have been discovered, but who knows what? More hidden secrets could be discovered. Number 4. Unraveling Saturn's fascinating background. When Voyager 1 got up close to Saturn, it discovered 5 new moons hanging around in or near Saturn's rings. These moons, Prometheus, Pandora, Atlas, Epimetheus, and Janus, are small and kind of lumpy in shape. They do an important job in keeping Saturn's rings in shape and stable by tugging on them with their gravity. People call them shepherd moons because they guide the particles in the rings. Voyager 1 also found out a lot about Saturn's rings. Instead of just being a simple ring, they're made up of billions of pieces of ice and rock. These pieces vary in size from tiny dust specks to big boulders. The way these bits interact with each other is pretty complex and interesting. Voyager 1's findings helped us understand more about how these rings change over time. Saturn's rings turned out to be full of surprises. Instead of being all the same, they have gaps, waves, braids, spokes, and kinks. These features are caused by how the ring particles interact with Saturn's moons. For example, Voyager 1 saw a big gap in one of the rings called the A ring. This gap is because of how the moon Mimas orbits Saturn. It's like a game of tug-of-war between gravity, and it clears a space in the ring. Also, Voyager 1 spotted a cool wave pattern in another ring, the B ring. This pattern happens because of how the moon Janus moves around Saturn. These patterns show us how lovely Saturn's rings are, thanks to the moons. Voyager 1 also saw some strange things in the B ring, like spokes. These spokes are probably caused by lightning in Saturn's atmosphere charging up the ring particles. Even though they don't stick around for long, they add to the mystery of Saturn's rings. Besides the rings, Voyager 1 checked out Saturn's magnetic field and magnetosphere. Saturn's magnetic field is like Earth's but much stronger and tilted differently. It's made by Saturn spinning and dealing with the solar wind. The magnetosphere around Saturn is a big space zone around the planet, stretching beyond the rings. It's full of plasma particles from Saturn's atmosphere, rings, and moons. Voyager 1 saw auroras, radio waves, plasma waves, and energetic particles, showing how complicated Saturn's magnetic environment is. Voyager 1 also learned a lot about Saturn's moons, including Titan, Enceladus, Mimas, Tethys, Dione, Rhea, Hyperion, Iapetus, and Phoebe. Titan has a thick atmosphere of nitrogen and methane, unlike any other moon in our solar system. Enceladus has a smooth, bright surface, hinting at geological activity and maybe an underground ocean. Mimas has a huge crater named Herschel that covers a big part of its surface. Iapetus has one dark side and one bright side, making it stand out in Saturn's moon family. Voyager 1's journey took it into the intense radiation belts surrounding Jupiter, caused by the planet's strong magnetic field mixing with solar winds. These belts are packed with energetic particles that can be risky for spacecraft and future missions. Also, Voyager 1 spotted lightning and auroras in Jupiter's atmosphere, plus radio signals that change as the planet rotates. These signals happen because electrons move along magnetic field lines and interact with plasma in Jupiter's magnetic space. Leaving Jupiter behind, Voyager 1 aimed for Saturn, its next big destination, leaving behind a trail of amazing discoveries. On November 12, 1980, Voyager 1 reached Saturn, passing by the planet about 124,000 kilometers away. During its journey, Voyager 1 also flew near Titan, Saturn's biggest moon, getting as close as about 6,190 kilometers. This special encounter marked the first time a spacecraft studied Titan's thick atmosphere up close, giving us valuable insights into this puzzling moon. Although Voyager 1 was the second spacecraft to visit Saturn after Pioneer 11, it stood out by revealing many secrets and surprises. Its flyby of Saturn on November 12, 1980, brought a ton of groundbreaking discoveries and observations that completely changed how we understand the ringed planet and its moons. One of the most exciting discoveries was finding a new ring around Saturn, call it the G-ring. This ring, which couldn't be seen from Earth before, is made up of tiny particles likely thrown out from the inner moons by meteoroid impacts. The G-ring is known for its faint and narrow structure, about 7,500 kilometers wide, with its inner edge located roughly 167,000 kilometers from Saturn's center. Moving forward from unveiling Saturn's mysteries to reaching interstellar space, NASA was now left with a new dilemma of trying to decode Voyager 1's messages from interstellar space. Number 5. Decoding Voyager. 1 Cosmic Code. On February 17, 1998, Voyager 1 made history by becoming the farthest human-made object from Earth, surpassing NASA's Pioneer 10. This amazing accomplishment marked a big moment in humanity's exploration of space. By August 16, 2006, Voyager 1 had traveled an incredible distance of 100 astronomical units from the Sun, showing it was in interstellar space. Even though it was billions of kilometers away from Earth, Voyager 1 kept communicating with its home planet. Positioned roughly 15 billion kilometers from the Sun, Voyager 1 acted as a symbol of human creativity, sending important data back to Earth across space. As Voyager 1 went deeper into space, its distance from Earth increased, reaching about 24 billion kilometers. Crossing into interstellar space was a huge achievement in human exploration, showing how important Voyager 1's mission was. However, lately, scientists and engineers at NASA have needed clarification on Voyager 1's messages. Instead of the expected data, the messages received looked like a strange series of ones and zeros. It seemed like Voyager had trouble communicating, struggling to share its observations in a way that people on Earth could understand. The source of this sudden silence was a problem between Voyager's flight data system FDS and its telemetry modulation unit TMU. These important parts, which collect data from space and send it back to Earth, had been disrupted by a mysterious malfunction, making scientists eager to figure out the issue. Interestingly, Voyager 1 carries a golden record, a time capsule of humanity's culture and achievements, meant for any extraterrestrial beings it might meet. This record has greetings in 55 languages, music from different cultures, and sounds from Earth, showing humanity's curiosity and creativity. Despite the communication problem, Voyager One's legacy continues to inspire scientists and space fans. Its journey through space has given us important information about our solar system and beyond. The strange thing found in Voyager One's messages was a real head-scratcher for NASA. It was a big deal because NASA had to figure out a way to turn important scientific info into a pattern of ones and zeros, like a mysterious echo, to keep from losing it forever. Instead of getting clear messages, NASA was getting some weird signal from the spacecraft. To tackle this problem, NASA's smart engineers came up with a plan called a poke. It was a gentle way to ask the spacecraft's data system to try something different, hoping to get around the part that was causing the trouble. But this poke wasn't just about fixing tech issues. It was like sending a message of hope, a way to reach out to our faraway space explorer. After months of quiet, Voyager 1 finally answered back with a faint but important signal. On March 3rd, NASA's Jet Propulsion Laboratory got an unexpected message. Instead of the usual data, they got a detailed report of everything Voyager had stored in its memory. Getting this unexpected signal was like finding a letter in a language nobody had used for ages, full of secrets that could save a mission in big trouble. It was like a light in the darkness of space, showing that Voyager 1 was still up and running and listening to our commands. The spacecraft's response was all thanks to a clever command that got it to send out a new kind of message. By telling Voyager to try different software sequences, engineers got it to send out crucial info about how it was doing. This breakthrough was a really big deal because it let engineers peek into Voyager's brain. They could compare the new info with what they already knew, helping them find the problem and figure out exactly how to fix it. From decoding Voyager's message to understanding its distant communication, NASA faces incredible challenges. Number 6. Overcoming light speed. Delays in interstellar conversations. Decoding the message from Voyager and fixing the problem is like searching for a tiny needle in an enormous haystack. This haystack isn't just big, it's over 15 billion miles away. Despite being so distant and traveling for so long, Voyager 1 still manages to send messages back to Earth. How is this possible? It's all thanks to the satellites and the Deep Space Network's DSN radio communication system. Voyager 1's radio system has a large antenna measuring about 12 feet across. This antenna can both send and receive radio waves through the 3 DSN stations on Earth. Mounted on a platform that can move and aim in any direction in space, the antenna is crucial for staying in touch with the spacecraft. The antenna uses 2 different sets of radio frequencies for communication, the S-band with a wavelength of about 5 inches and the X-band with a wavelength of about 1.5 inches. The S-band is mainly used for sending commands and technical data, while the X-band is used for sending scientific data and pictures back to Earth. The DSN is a network of large radio antennas located in different parts of the world, including Canberra in Australia, Madrid in Spain, and Goldstone in California. These locations are chosen carefully and spread out around the planet so that at least one site always has a clear view of Voyager 1 as Earth rotates. Each site has several antennas, with the biggest one being about 230 feet across. This large size is necessary to pick up the very weak signals sent by Voyager 1, which are about 20 billion times weaker than what's needed to power a digital watch. Despite the amazing technology and coordination involved, communication between Voyager 1 and Earth is not instant. Because radio signals travel at the speed of light, which is about 786,000 miles per hour, there's still a delay depending on how far away the spacecraft is from Earth. Voyager 1, a spacecraft sent out by NASA, is now incredibly far from Earth. It's so far away that it takes a staggering 21 hours for a signal to travel from Voyager 1 to Earth or vice versa. Imagine sending a message to a friend, but they only get it the next day. This delay means that when NASA sends a command to Voyager 1, they have to wait patiently for 21 hours to get confirmation that the command worked. Likewise, when Voyager 1 sends back data or pictures to Earth, it takes another 21 hours for NASA to get them. As Voyager 1 journeys further, maintaining contact faces challenges, yet it persistently shares discoveries. Number 7. Navigating space. Communication challenges. Communication between Voyager 1 and Earth isn't constant. It relies on things like how much power is available, how quickly data can be sent, how precisely the antenna is pointed, and any disruptions from other sources. Voyager 1 gets power from something called radioisotope thermoelectric generators, RTGs, but these lose power over time, so it needs to carefully choose which tools and systems to use to save energy. As Voyager 1 moves away from Earth, it sends data more slowly because the signal gets weaker with distance. Even a small mistake in pointing the antenna can cause the signal to disappear, showing how precise communication needs to be. Also, things like the Sun, other planets, or other spacecraft can mess up communication. But despite these problems, Voyager 1 keeps sending important data and pictures back to Earth using its radio system and the Deep Space Network, DSN. It also gets instructions and updates from Earth to stay working correctly. This communication shows how smart and curious humans are. Voyager 1 has been working with NASA for over 40 years now. But what's happening to Voyager 1 out in space? We're still figuring that out as it explores the unknown. Speaking of space, it's not just empty. It's full of different stuff like gas, dust, cosmic rays, and even things like dark matter, but they're spread out thinly, making space almost empty. One way to know when you're leaving our solar system is by looking at how much the Sun and other stars influence the space around them. The Sun sends out a constant stream of particles and magnetic fields called the solar wind, which makes a big bubble around our solar system called the heliosphere. This bubble protects our planets from most stuff in space. It goes out to about 122 times the distance between Earth and the Sun. At the edge of the heliosphere, the solar wind meets the space between stars, which is called the interstellar medium, ISM. The ISM pushes against the heliosphere, making a shock wave called the termination shock. This shock wave is where the solar wind starts mixing with the space between stars, getting hotter and denser. The edge of this mixed-up area is called the heliopause, and that's where the Sun's influence ends. Voyager. One's journey into space between stars is incredible, but finding extra space rays and changed magnetic fields was one feat by the Voyager missions that had the entire scientific space buzzing. Number 8. Voyager 1's encounter with interstellar space. Traveling beyond the area where the Sun's influence ends, Voyager 1 journeyed into the real space between stars, where space stuff dominates over the Sun's breeze. Voyager 1's main goal was to explore this space and study its unique features. However, knowing when it left the area controlled by the Sun was hard because there was no clear boundary. Voyager 1 used its tools to measure different things like how many charged particles were around, how strong and which way the magnetic field was, how many cosmic rays there were, and the patterns in the charged particles' movement. Voyager 1 first hinted at nearing the space between stars in May 2012, when it noticed a sudden increase in cosmic rays. These powerful particles coming from outside our solar system suggested that Voyager 1 was leaving the Sun's protective bubble and entering a place full of cosmic rays. Another sign came in June 2012 when Voyager 1 saw fewer particles from the Sun's breeze, showing it was moving away from where these particles came from. But this alone wasn't enough to be sure it was in the space between stars, as other things could affect how many solar breeze particles there are. The big moment came in August 2012 when Voyager 1 noticed a big change in how many charged particles there were and how the magnetic field was pointing. Charged particles make up plasma, which can carry electricity and make magnetic fields. Voyager 1 used its tool to measure plasma, finding out how much there was, and seeing the patterns in it caused by different things. On August 25, 2012, Voyager 1 saw a big jump in plasma from about 0.002 to 0.08 per cubic centimeter. This showed Voyager 1 had entered a place where there was more plasma than in the sun's bubble. Also, Voyager 1 used its tool to measure magnetic fields, seeing how strong they were and which way they pointed, noticing changes caused by electricity or moving charges. At the same time, Voyager 1 saw the magnetic field change by about 20 degrees. This showed Voyager 1 had entered a place where the magnetic fields were different compared to inside the sun's bubble. These two measurements together proved Voyager 1 had entered the space between stars. But it took a while to confirm this big achievement. Because it's so far from Earth, it took about 17 hours for Voyager 1's signals to reach us, and it took several months for scientists to carefully check and agree on Voyager 1's data before telling everyone about this in September 2013. What are your thoughts on this groundbreaking and almost impossible discovery made by Voyager 1? Let us know your opinions in the comments below. And if you enjoyed watching this video, make sure to give it a thumbs up and subscribe to the channel.